All right, so now we are going to apply finding the max or min, the extreme values of functions, by putting them into word problems. So what we're going to do is we'll find the equation that comes as a result of the word problem. Then we're going to find the minimum or the maximum by finding the critical numbers. That means setting the derivative equal to 0 or doesn't exist. Most of the time it will be equal to 0. And most of the time, there's just a couple of rare cases where we'll have more than one critical number. So the one critical number that will make sense, that will give us the maximum or the minimum. All right, so let's dig in. So many times we're going to have two equations. So one I'll call the constraint, and the constraint, okay, pen. The constraint is going to be that which we are restricted by. So two numbers whose difference is 100. So x minus y is equal to 100. Okay, so there's going to be something I'm going to want to minimize, and this one is the product. So this is the minimize. So it's going to be the product, and I'll say p, and I'm going to write down what it is. It's going to be x times y. So in my head, I'm thinking it's p that I want to take the derivative of and set equal to 0. So I see that I've got my product function in two variables. That's not good. So I want to rewrite this with one variable, and that's where the constraint comes to the rescue. So this is easily solved for x. So let's solve x equal 100 plus y. Let's substitute it into p. So I'd have 100 plus y times y. And just because I can, and I can see it's going to be easier to take the derivative if I multiply this out, I'm going to. So that's the equation that I want to take the derivative of and set equal to 0. So I can see it's got a parabola, so it's going to give me one critical number, so I get 100 plus 2y. I'm going to set that equal to 0, so I get y is equal to negative 50. And so that's one of the numbers, and the other number I'll find by plugging that into x minus y equal 100. So if I plug in negative and 50 in here, I get x equal positive 50, 100. So that gives me y equal 50. So these two numbers, that was x. So these two numbers, x is 50, y is negative 50. This gives me the minimum product and the difference which is 100. All right, so let's look at the dimensions of a rectangle. Rectangle having perimeter 100 meters. So a rectangle, I'm going to get a picture going here. So I see x's and y's, right? So if I've got a perimeter of 100, that means I have 2 x's plus 2 y's equaling 100. Okay, so that's my constraint. That's what I'm restricted by. And what is it that I want to make as large as possible? So that means maximize, right? So what I want to maximize is area. So the equation for area, make sure you use the same letters that you've got in your equation in your constraint. And so my area is going to be x times y. And again, I'm thinking this is the one I want to take the derivative of and set equal to 0, because this is what I'm trying to maximize. All right, so I see that I want to solve for one of my letters here. So I'm going to solve for x this time. So this gives me 50 minus y is equal to x. So substituting that into a, 50 minus y times y. So 50y minus y squared. All right, so let's take the derivative. So I get 50 minus 2y. Set that equal to 0. So that gives me 25. So it's my job to go find out what the x is equal to as a result. So using x equal 50 minus y, I get x is equal to 25. So x is 25, y is 25. I have a square.